Hey guys, this is Mrs. Hardman, and we are going to take a look at perimeter today in our geometry unit. We've already been talking about perimeter in each of our previous lessons, but we're just going to focus on it a little bit more in detail today and find some perimeter, some measurements of some more complex shapes. But let's start off with our objectives. So our biblical correlation comes from Colossians 1:16 through 17, which says, "For by him all things were created, things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities, all things were created by him and for him. He is before all things, and in him all things hold together." And in math, we frequently talk about how God is a God of order, and he has created things with detail and with patterns, and we're using math to describe the order that he's already created. And he's created the things that are visible and also those things that are invisible, whether we're talking about atoms or molecules or even just the invisible patterns like we see with the Pythagorean theorem. We know that he's created all of those things for us to use. Our specific objective for today is that you will review formulas for finding perimeter and find the perimeter of various geometric shapes. So let's dive right in. Perimeter, you should know, is the distance around a two-dimensional shape. We use the word perimeter not just in math, but also out in the real world. You'll hear perimeter used to describe houses when you go house shopping, when you're buying fencing, or in police and military, they'll talk about securing the perimeter, and that's just the distance around a shape. And the way that we find perimeter, the easiest explanation is just to add up all the sides. Yes, there are formulas for the different shapes, but really, if you just remember add up all the sides, that's all you need to know. So we have this rectangle here with two sides of 7 and two sides of 3. And we're going to find the perimeter of this rectangle by adding up all the sides. So we can do 7 plus 3 plus 7 plus 3, or 7 plus 7 and 3 plus 3, or 2 times 7 and 2 times 3, and add those together. No matter how we add it, we do get 20. And because we're not told the units, we're just going to go ahead and write the word units in here. 20 units. We don't know if it's inches, feet, miles, yards. We don't know. So we'll write units. Right? If you're finding the perimeter of a regular shape, a regular polygon, remember that regular means all the sides are the same. So even if you hadn't been told what these other sides were, if they had no numbers there, and you were just told this was a regular pentagon, and that this side was 3, you can deduce that the other sides are 3 as well. And to find the perimeter, we add up all the sides. We can add 3 plus 3 plus 3 plus 3 plus 3, or since we have 5 sides that are 3, we could use some multiplication. Either way, we get that our perimeter is 15. Again, we're not told the unit, so we're just going to write units. 15 units. Please remember, regular does mean all the sides are the same. So even if you're not specifically told the other sides, you know that regular means all sides are the same, and you can deduce what the other sides are. And when we're talking about perimeter of two-dimensional shapes, we can't leave out the word circumference. Circumference is a word that's referring specifically to circles, and it's really the perimeter of a circle. So the distance around the circle there. You can see we have the parts of our circle labeled. We've got the circumference labeled right here, and the radius is the distance from the center of the circle to the edge. And to find the circumference of a circle, we take 2 times pi times the radius, or 2 pi r. Because twice the radius is also called the diameter, sometimes you'll see circumference listed as this. It's just the diameter times pi. As a reminder, pi is not a variable. It is a number. It is a constant number, the 3.14159, etc., etc. We just can't list the entirety of the number because it never repeats, and so we use pi as the symbol to represent that number. If you are typing this into your calculator, you do have a pi button on your calculator to help you figure out what that might be as a decimal measure rounded. So the circumference or perimeter of a circle is 2 pi r, or sometimes we'll see it as pi times the diameter. We have, like I said previously, some perimeter formulas. You don't need to spend a lot of time memorizing these formulas. It's just helpful to see them. As long as you remember that perimeter means add up all the sides, that's all you need to know. When we're talking about a triangle, that means we're going to be adding 3 sides, a plus b plus c. When we're talking about a square, since a square is a regular polygon and all the sides are the same, We really just need to know one side, and then we can take 4 times that one side. For a triangle, we're going to add up the width and the height. And because the width is going to be the same on both sides and the height is going to be the same on both sides, we can do 2 times the width and 2 times the height. Sometimes you'll see instead of width and height, you'll see an L for width and length. It's the same thing. So add up all 4 sides. Any other quadrilateral, again, we just add up all of the sides. A, B, C, D. Doesn't matter if we're talking about quadrilaterals or really any polygon. Hexagons, pentagons, heptagons, nonagons. You just add up all the sides. So let's take a look at some complex shapes that don't fall under our typical polygon organization chart. So we've got this shape right here, and we want to find the perimeter. Again, we want to add up all the sides. So we know this side is 7, this side is 5, this side is 4, this side is 3, but we're missing this side, 2 sides that we're missing. But we can use the other measurements that we have here to help us figure out those 2 sides. One of the ways that we can do that is to divide our shape into 2 smaller shapes. Right, so if I know that this whole side is 7, and this part from here to here is 4, so from here to here is 4, I can use some simple math, take my total of 7 from here to here, subtract the 4 that I know, and that tells me that this side must be 3. Now it is a rectangle, so that means the other side must also be 3. And then if I know from here to here is 5, and I know that this much is 3, well, I can deduce that 5 minus 3 is 2, so that this must be 2 and 2. Now, once I've got those missing lengths labeled of that rectangle there, I can then proceed to add up all of the sides. So I've got 7 plus 5 plus 4 plus 3 plus 3 plus 2. We've got 43. That should not be meters squared. That should be 43 here. And this formula right here, I think is for the next slide. I don't think that fits with this slide. Let's try this again. We've got 7 plus 2 plus 3 plus 3 again plus 4 plus 5. And then I'm going to make some groups of, we got 9 here and 6 and 9 again. 9 plus 6 is 15, and 15 plus another 9 is 24. That is 24. In this case, we do have the unit, 24 centimeters. I think all of this is on the wrong side. So we've got 24 centimeters in this particular shape. All right, now let's take a look at a different complex shape. We do know that this side is 12, this side is 6, and we're told that from here to here, let me draw that dotted line, is 6. We are going to have to use the Pythagorean theorem then, because these are right triangles, to find this hypotenuse, the length of that side. Now, here's what we saw on the previous slide. A squared plus b squared is c squared. There's our Pythagorean theorem. We know that this side is 6 and this side is 3, so we can plug those in. 6 squared plus 3 squared gives us 36 plus 9. And that's going to be our c squared. So if we take the square root of that, we get approximately 6.7 for the length of those 2 sides. Now that we know all of our sides, we can find the perimeter. So 12 plus 6 plus 12 plus 6.7 plus 6.7 is approximately 43.4 meters. Not squared, just meters. We do have to use the approximate sign because we did have to round when we took the square root there. All right, let's try one final shape here. All right, let's think again about what we know. We know that the bottom side is 6 because it's like a rectangle with a piece taken out here. I'm going to draw that missing side there. If this side is 6, then this side is also 6. We don't know the long side and we don't know the arced side. Now this is just half a circle. So I can find the perimeter, imagining that this was a whole circle. I can find the perimeter of this circle and then just cut it in half because I only want to know what this half is. Remember that the perimeter or the circumference of a circle is 2 pi r. And we're going to cut that in half because we only want to know half of that circle. When we plug in our radius as 4, which we're told right here, plug that into a calculator, multiply that by 2 and pi, and then cut it in half, we get approximately 12.57. So 12.57 is the length of this arc right here. Now we still need to know this side right here. Well, that side is just the same length as the diameter of the circle. Remember, diameter is the distance through the middle from one side of the circle to the other. Well, if the radius of the circle is 4, if halfway is 4, then I know that the other half must be 4. So that tells me my diameter is 8. And if the distance of this line is 8, then the distance of this line, or the length of this line, must also be 8. All right, now that we have all of our sides, we have 6 plus 8 plus 6 plus 12.57. We are ready to find our perimeter by adding up all the sides. And we get approximately 35.43. And we're told our unit of measure here is inches. So let's go ahead and add that. 35.43 inches. All right, today, guys, we found the perimeter of various geometric shapes. The easiest way to remember to find the perimeter is just to add up all the sides. You may have to use a circumference formula or another formula to help you find some of the missing sides. But once we have all the sides lengths, we can add those together. Please don't forget your unit of measure. If you have any questions, write those down, and I'll see you next class.